right, class, today we're going to talk about graphing rational functions. This is the final section of section 6.4. Okay, so there's a couple things we're going to have to keep in mind when we're graphing rational functions. So let's take a look at what those are. So it's important to remember that with a rational function, I have a function in my numerator and a function in my denominator. And one thing that's really important is that my denominator cannot equal 0. So what do? We set our denominator equal to 0 in order to find our domain. So I would have x equals 0. That means that x cannot be equal to 0. So my domain would be, let's write that out, my domain would be all values of x as long as x doesn't equal 0. Now something really special happens when x does equal 0 and we're trying to graph our function. We get a vertical asymptote. Remember that the graph of x equals 0, if this was a line, would be a vertical line, so we get a vertical asymptote. And that's because our function will never have x equal to 0. Now let's look at our equation here, y equals 1 over x. We're also going to see that y would never equal 0. Let's take a look at this. So if I have x equal to -2, -1, and if I have x equal to 2 and 1, we're going to go ahead and find our y. So if x is -2, y would be -1/2. If x is -1, y equals 1 divided by x, so 1 divided by -1 is going to be a -1. If x equals 2, I have y equals 1/2. If x equals 1, I have y equals 1. And if x equals 3, I have y equals 1/3. Okay? So what's happening here as x gets further away from 0, y gets smaller and smaller and smaller. So as x gets more and more negative, y gets closer and closer to 0. And here, as x gets bigger and bigger, y gets closer and closer to 0. But y will never equal 0 because 1 divided by our x value, no matter how big it is never going to be equal to 0. So you have a horizontal asymptote at y equals 0. Remember that y equals 0, if we were to graph that line, is a horizontal line. Let's take a look at another rational function. So what if I have y equals 1 over x squared? This is still going to have a vertical asymptote at x equals 0 because I would set our denominator equal to 0 and solve. We'll talk more about square roots in chapter 7. I also have a horizontal asymptote again because 1 divided by an x value, no matter how big, this is going to make y get really, really small as x gets bigger and bigger and bigger, but it's never going to be equal to 0. So when we're graphing our rational functions, we want to make sure we find our domain, and we're going to have to determine what the asymptotes are. This will help us figure out how to graph our equation. So, vertical asymptotes form when you would need to divide by 0. So this is when x is equal to some constant. And horizontal asymptotes help us determine the end behavior of our graphs. So first off, let's practice finding asymptotes. So here are the rules for determining asymptotes, okay? To find the asymptotes of rational functions, to find the vertical asymptote, you would set the denominator equal to 0. To find our other asymptotes, like horizontal asymptotes, there are some rules. So if the numerator has a lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. If the numerator and the denominator have the same degree, and the function is of the form f of x equals an, bn, where an and bn are the constants in front of our x's with the same degree value, then our horizontal asymptote is at y equals an over bn. And lastly, if the numerator is of degree exactly 1 more than the denominator, then there'll be an oblique asymptote, okay? We're going to go through how to find all of these. So we're going to start with step 1, which is vertical asymptotes. So if I have x squared minus 1, that's the difference. That's the product of a sum and a difference. So this, I'm going to set it equal to 0, and then I need to factor it. Well, I know it factors to x plus 1 times x minus 1 equals 0, because x squared is a perfect square and 1 is a perfect square. Now I use the zero factor property. So I take x plus 1 equals 0 and x minus 1 equals 0. And I determined that I'm actually going to have two vertical asymptotes, which is okay. I have vertical asymptotes at x equals negative 1 and x equals positive 1. Next, I want to determine my horizontal asymptote. So, if the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Well, my numerator has a degree of 1, but my denominator has a degree of 2. So my numerator is of lesser degree than my denominator, so I have a horizontal asymptote at y equals 0. Okay, example 2. I have 3x squared over 2x squared minus 1. And I want to find my vertical asymptotes. So what I need to do is I need to set my denominator equal to 0. So I have 2x squared equals negative 1. I'm going to have to go ahead and divide both sides by 2. So I get x squared equals negative 1/2. Okay. I take the square root of both sides. Okay. So that means I have the square root of a negative, which I can't do. We can't take the square root of negative numbers, and we're going to talk about that more in chapter 7. Luckily for me, there are no horizontal asymptotes here. And vertical asymptotes here. And let's talk about why. So my denominator will never equal 0 because I always have 2x squared minus 1. So if I had x equal to 0, I'd have a denominator of negative 1. If I have x equal to 1, I'd have a denominator of 1. And if I had x equal to positive 1, I'd get 1 squared times 2 minus 1, which is just 1. Okay? So because my denominator can never be equal to 0, there are no vertical asymptotes. Okay? And this was a special case of our domain, which we talked about in the beginning of section 6.1. It's always nice to know that you can figure out you made a mistake. You can't take a square root of a negative. That's a good way to catch yourself. So we've got no vertical asymptotes. Let's take a look at horizontal asymptotes. If the numerator has lesser degree than the denominator, then there is a horizontal asymptote at y equals 0. My numerator and my denominator both have a degree of 2, so that's not the answer. B, if the numerator and the denominator have the same degree and the function is of this form, which it is, our horizontal asymptote is going to be at y equals our constant in our numerator divided by our constant in our denominator. So I have y equals 3/2 is my horizontal asymptote. Last but certainly not least, in an example of finding asymptotes, I need to find the vertical asymptote of x squared over x plus 1. So I set my denominator equal to 0. I solve for x. So I have a vertical asymptote when x equals negative 1. Now I need to look for my horizontal asymptotes. Okay? I have, if the numerator is lesser degree than the denominator, then there is a horizontal asymptote at y equals 0. My numerator's degree is 2. My denominator's degree is 1. So that's not the case. Next, if the numerator and the denominator have the same degree, I'd have a horizontal asymptote of this form, but they do not have the same degree, so it's not going to be case B, it's got to be C, right? So if the numerator is of degree exactly one more than the denominator, then there will be an oblique or slanted asymptote. Now to find that, we divide the numerator by the denominator and disregard the remainder, okay? And y equal to the rest of what we have left over will give us our equation for our asymptote. So I'm going to take x squared divided by x plus 1. I'm taking my numerator divided by our denominator. What do I multiply by x to get x squared? That's going to give me x. So x times x gives me x squared. X times 1 gives me x. I subtract this. That gives me 0 with a remainder of negative x, right? Because I have 0x up here. So I would just have a horizontal asymptote at y equals x because we ignore the remainder. We only care about what fit perfectly. So why don't we go ahead and graph a couple of these? An important thing to note is if my degree is even, it's going to be, our graph will be on either the top or the bottom, right? They go the same direction. And if my degree is odd, then they're going to go in opposite directions. But we would have seen that anyways when we start to calculate some x values. So let's take a look at 2 over x minus 3. Okay, we need to figure out my asymptotes. So to find my vertical asymptote, I have x minus 3 equals 0. So I have a vertical asymptote at x equals 3. That means when x is 3, my graph will not cross this line. All right, let's see about our horizontal asymptotes. When my degree of my numerator, the degree of this is 0, is less than the degree of my denominator, this has a degree of 1, I have a horizontal asymptote at y equals 0. So my domain, so here's our horizontal asymptote. So my domain is going to be all values of x as long as x doesn't equal 3. And my range is going to be all values of y as long as y doesn't equal 0. Now, I need to graph this bad boy, so I better figure out how to plot some points. My suggestion is to pick 3 points on each side of your vertical asymptote. So I'm going to have x equal to 0, 1, and 2. And I'm going to have x equal to 4, 5, and 6. So I've got 0, 1, 2, 4, 5, 6. When x is 0, y is 2 divided by negative 3, so negative 2/3. When x is 1, y is 2 over negative 2, so just 1. And when x is 2, I get 2 over negative 1, so it's just going to be a negative 2. So when x is 0, y is negative 2/3. Let's change colors so we can see this a little bit better. Okay, when x is 0, y is negative 2/3. When x is 1, y is negative 1. When x is negative 2, when x is positive 2, y is negative 2. Now, I know my graph is going to approach my asymptotes, but it's never going to cross them. So here's what this half of my graph would look like. Now, let's take a look at when x is 4. 2 divided by 4 minus 3, that's 2 over 1, which gives me a 2. 2 divided by 5 minus 3, that's 2 over 2, which is a 1. And 2 divided by 6 minus 3, that's going to give me a positive 2/3. Notice the symmetry here. Symmetry. All right, let's go ahead and graph these points. I have when x is 4, y is 2. When x is 5, y is 1. When x is 6, y is 2/3. My graph approaches my asymptotes but never crosses them. So here is our graph. Next, I have f of x equals 1 over x squared minus 9. So I need to take my denominator and set it equal to 0. So I've got x squared minus 9 equals 0. And I'm going to go ahead and factor this. This gives me an x plus 3 times an x minus 3 equals 0. I take each of my factors and set them equal to 0. So I get x equals negative 3 and x equals 3. So these are my vertical asymptotes. X equals negative 3 and x equals 3. I am going to have a horizontal asymptote because the degree of my numerator is less than the degree of my denominator. So I also have an asymptote at y equals 0. So let's go ahead and sketch in our asymptotes. Here I have my horizontal asymptote at y equals 0. Here I have my vertical asymptote at x equals negative 3 and at x equals positive 3. Okay, now my graph is broken up into 3 sections. So I'm going to pick 3 points from each of my 3 sections in order to graph this. But first, my domain is all values of x as long as x does not equal either of our asymptotes. And my range is all values of y as long as y doesn't equal 0. Okay, so I need to pick a whole bunch of x values. I have x when x is, how about negative 4, negative 5, negative 6? I'm going to have x when y is, x when it is 0, negative 1, and positive 1. 0, negative 1. And I'm going to have y, I'm going to have x when I have 4, 5, and 6. Okay. So if x is negative 4, I have negative 4 squared. That gives me a positive 16. 16 minus 9 is 7, so I have 1/7. When x is negative 5, I have 25 minus 9 under 1. So 25 minus 9 is 14, so I get 1/14. Now let's say I have 6. 6 squared is 36. 36 minus 9 is 27. Oh my gosh. So I have 1/27. These are really tiny numbers. Let's go ahead and graph them as best we can. So when x is negative 4, y is 1/7. And that's a positive 1/7, by the way. Does that look like a 7th? I think so. When x is negative 5, one's negative 14th. And when x is negative 6, y is 1/27. That's really tiny. So my graph is going to do this. It's going to get really, really close to the asymptote, but never cross it. Now, let's go ahead and take a look at what happens when x is 1. I get 1 over 1 squared minus 9. 1 squared is 1. 1 minus 9 gives me a negative 8, so I have negative 1/8. When x is 0, when x is 0, I have 1 over negative 9, so negative 1/9. And when x is negative 1, negative 1 squared is a positive 1. 1 minus 8 gives me a negative 8, so I have negative 1/8. Okay, so I have negative 9, negative 1/9. When x is 0, I have negative 1/9. When x is 1 or negative 1, I have negative 1/8, which is a little bit bigger than negative 1/9. So my graph is going to look like this, and it's not going to cross any of these vertical or horizontal asymptotes. Now, remember, we've got some symmetry going on here. So you'll see if you go ahead and plug in 4, you'd get y is 1/7, just like when it was negative 4. You'll get 1/14, just like when it was a negative 5. And you will get 1/27. So my graph is going to look like this. And that's everything I wanted to cover for chapter 6. Be sure to reach out to me with your questions.